Hi, good day everyone. This is Brian Deneros. Our subject for this lesson is engineering economics. This will be our first lesson, an introduction to some of the concepts on and principles in engineering economics. Will be discussed in this particular lesson. Okay, so let's start. So, the technological and social environment in which we live continue to change at a rapid rate. In the recent decades, advances in science and engineering have transformed our transportation systems, revolutionized the practice of medicine, and miniaturized electronic circuits so that a computer can be placed on a semiconductor chip. The list of such achievement seems almost endless. In your science and engineering courses, you will learn about some of the physical laws that underlie these accomplishments. The utilization of scientific and engineering knowledge for our benefit is achieved through the design of things we use, such as furnaces for vaporizing trash and structures for supporting magnetic railways. However, these achievements don't occur without a price, or monetary or otherwise. Therefore, the purpose of this subject is to develop and illustrate the principles and methodology required to answer the basic economic question of any design. Okay? That is, the question is, do uh, its benefits exceeds or do its benefits exceed its costs? We can define engineering as the profession in which a knowledge of the mathematical and natural science gained by study, experience, and practice is applied with judgment to develop ways to utilize economically and the materials and forces of nature for the benefit of mankind. So, in this definition, the economic aspects of engineering are emphasized, okay, as well as the physical aspects. Clearly, it is essential that the economic part of engineering practice shall be accomplished well. Therefore, engineers use knowledge to find new ways of doing things economically. So let us define engineering economy. Okay? Engineering economy involves the systematic evaluation of the economic merits of proposed solutions to engineering problems to be economically acceptable, or let's say affordable. Solutions to engineering problems must demonstrate a positive balance of long-term benefits over long-term costs, and they must also promote the well-being and survival of an organization. They must embody creative and innovative technology and ideas. They must also permit identification and scrutiny of their estimated outcomes, and they must translate profitability to the bottom line through a valid and acceptable measure of merit. So, engineering economy is the dollars and cents side of the decisions that engineers make or recommend as they work to position a firm to be profitable in a highly competitive marketplace. Inherent to these decisions are trade offs among different kinds of costs and the performance provided by the proposed design or solution. So, the mission of engineering economy is to balance these trade offs in the most economical manner. I repeat, the mission of engineering economy is to balance these trade offs in the most economical manner. Okay? An engineering economy study is accomplished using a structured procedure and mathematical modeling techniques. The economic results are then used in a decision situation that normally includes other engineering knowledge and input. Okay. The development, study, and application of any discipline must begin with a basic foundation. We define the foundation of engineering economy to be a set of principles that provide a comprehensive doctrine that for developing the methodology. These principles will be uh, discussed in the following slides. So let's begin with the first principle, uh, develop alternatives. Okay, so in this principle, we should carefully define the problem. Then the choice or a decision is, of course, among those alternatives. Okay? The alternatives need to be identified and then defined for subsequent analysis. So, a decision situation involves making a choice among two or more alternatives. Developing and defining the alternatives for detailed evaluation is important because of the resulting impact on the quality of decision. So, engineers and managers should place a high priority on this uh, responsibility. So, creativity and innovation are essential in this process. One alternative may be feasible in a decision situation is making no change to the current operation or set of conditions. If you judge this option feasible, make sure it is considered in the analysis. However, do not focus on the status quo to, uh, to the detriment of innovative or necessary change. So, principle number one, we must develop alternatives. Okay, next, principle number two, focus on the differences. Only the differences in the expected future outcomes among the alternatives are relevant to their comparison and should be considered in the decision. If all if all prospective outcomes of the feasible alternatives were exactly the same, there would be no basis or the need for comparison. We would be indifferent among the alternatives and could make a decision using random selection. Obviously, only the differences in the future outcomes of the alternatives are important. Outcomes that are common to these alternatives can be disregarded. Uh, for example, if your feasible housing alternatives were two residences with the same purchase price, price would be uh, consequential to your final choice because you have the same purchase price. Instead, the decision would depend on other factors such as location, the annual operating and maintenance expenses, etc. So this simple example illustrates this second principle, focus on differences, which emphasizes the basic purpose of an engineering economic analysis. So we should recommend a future course of action based on the differences among feasible alternatives. Okay, so that's principle number two, focus on the differences. Principle number three, okay, use a consistent viewpoint. So the prospective outcomes of alternatives economic, and other, should be consistently developed from a defined viewpoint or perspective. The perspective of the decision maker, which is often the owners of a firm, would normally be used. However, it is important that the viewpoint for the particular decision be first defined and then used consistently in the description, analysis, and comparison of the alternatives. As an example, consider a public organization operating for the purpose of developing a river basin, including the generation, wholesale distribution of electricity from the dam on the river system. A program is being planned to upgrade and increase the capacity of the power generators at the two sites. So the question is, what perspective should be used in defining the technical alternatives for this program? The owners of the firm in this example means the segment of the public that will pay the cost of the program. And their viewpoint or perspective should be adopted in this particular situation. Now, let us look at an example where the viewpoint may not be that of the owners of the firm. Suppose that the company in this example is a private firm and that the problem deals with providing a flexible benefits uh, package for their employees. Also, assume that the feasible alternatives for operating the plan have all have the same future costs to the company. The alternatives, however, have differences from the perspective of the employees, and their satisfaction is an important decision criterion, right? The view the viewpoint for this analysis should be that of the employees as a group, and the feasible alternatives should be defined from their viewpoint. Okay, so in principle number three, use a consistent viewpoint. Next, uh, principle number four, use a common unit of measure. This is very important. Using a common unit of measurement to enumerate as many of the prospective outcomes as possible will simplify the analysis of the alternatives. Of course, it is desirable to make as many prospective outcomes as possible commensurable, or let's just say directly comparable. For economic consequences, a monetary unit such as dollars or peso is the common measure. So we should also try to translate other outcomes, which do not initially appear as to be economic, into some form of monetary unit. This translation, of course, will not be feasible with some of the outcomes, but the additional effort toward this goal will enhance commensurability and make the subsequent analysis of the alternatives easier. Okay? So again, we should also try to translate other outcomes into the monetary unit. Okay? So what should we do with the outcomes that are not economic? For example, the expected consequences that cannot be translated or estimated using the monetary unit. So what should we do? First, if possible, quantify the expected future results using an appropriate unit of measure for each outcome. If this is not feasible for one or more outcomes, describe these consequences explicitly so that the information is useful to the decision maker in the comparison of the alternatives. Okay? So principle number four, use a common unit of measure. Principle number five, Consider all relevant criteria or idea. So, selection of a preferred alternative in the decision making requires the use of a criterion or several criteria. The decision process should consider both the outcomes enumerated in the monetary unit and those expressed in some other unit of measurement or made explicit in a descriptive manner. Okay, so uh, to further explain, consider the decision maker will normally select the alternative that will best serve the long-term interests of the owners on an organization. In engineering economic analysis, the primary criterion relates to the long-term financial interests of the owners. This is based on the assumption that available capital will be allocated to provide maximum monetary return to the owners. Often, though, there are other organizational objectives you would like to achieve with your decision, and these should be considered and given weight in the selection of an alternative. These non-monetary attributes and multiple objectives become the basis for additional criteria in the decision-making process. Okay, so principle number 5: consider all relevant idea or criteria. Principle number 6: make risk and uncertainty explicit. Okay, principle number 6: make risk and uncertainty explicit. What do we mean by that? Risks and uncertainty are inherent in estimating the future outcomes of the alternatives. And of course, we should be it should they should be recognized in the analysis and comparison. The analysis of alternatives involves projecting or estimating the future consequences associated with each other. The magnitude and the impact of future outcomes may be uncertain, even if the alternatives involves no change from current operations. The probability is high that today's estimates of, for example, future cash receipts and expenses, so these estimates will not be what eventually occurs. Therefore, dealing with uncertainty is an important aspect of engineering economic analysis. Okay, so therefore, in principle number 6, we should make risk and uncertainty explicit. Okay, and the last principle, principle number 7, uh, revisit your decisions. Okay? Improved decisions making results from an adaptive process to the extent practicable. The initial projected outcomes of the selected alternatives should be subsequently compared with the actual results achieved. Okay? So this principle is very important. So a good decision-making process can result in a decision that has an undesirable outcome. Okay? Other decisions, even though relatively successful, will have results significantly different from the initial estimates of the consequences. So, what's the principle? Learning, learning from and adapting based on our experience are essential and are indicators of a good organization. The evaluation and results versus the initial estimates of the outcomes is often considered impracticable or not worth the effort. Too often, no feedback to the decision making process occurs. So, organizational discipline is needed to ensure that the implemented decisions are routinely post-evaluated and that the results are used to improve future analysis and the quality of decision making. Just for an example, a common mistake made in the comparison of alternatives is the failure to examine adequately the impact of uncertainty in the estimates for selected factors on a particular decision. Only post-evaluations will highlight this type of weakness in the engineering economy studies being done in an organization. So principle number 7, revisit your decisions, okay? Because there are learnings we can get by revisiting what the decisions achieved, okay, or the results achieved. So in this slide, we'll discuss the engineering economy and the design process. So an engineering economy study is accomplished using a structured procedure and mathematical modeling techniques. The economic results are then used in a decision situation that normally includes other engineering knowledge and input. A sound engineering economic analysis incorporates the basic principles we have discussed, right? Uh, and it involves several steps. We can represent the procedure in terms of the 7 steps listed in this table. Okay? There are several feedback loops within the procedure. So the 7-step procedure is also used to assist decision making within the engineering design process. So we have the engineering design process at the right hand column of this table. So in this case, activities in the design process contribute information to the related steps in the economic analysis procedure. So this relationship, okay, between the activities and the steps in the engineering economic analysis are shown in this figure. So to define the engineering and design process may be repeated in phases to accomplish a total design effort. For example, in the first phase, a full cycle of the process may be undertaken to select a conceptual or preliminary design alternative. Then, in the second phase, the activities are repeated to develop the preferred detailed design. And then, on the next phase, this process may be repeated again until we come up with the actual design. Okay, so let's discuss the procedures uh, in this engineering economic analysis. Okay, first, uh, problem recognition, definition, and evaluation. So the first step of the engineering economic analysis procedure is particularly important. So since it provides the basis for the rest of our analysis. A problem must be well understood and stated in an explicit form before the project team proceeds with the rest of the analysis. The term problem is used generically. So it includes all decision situations for which an engineering economic analysis is required. So recognition of the problem is normally stimulated by internal or external organizational requirements. An operating problem within a company or a customer expectation about a particular product or service are common examples. Once the problem is recognized, its formulation should be viewed from a systems perspective. So, what is a perspective? That is the boundary or the extent of the situation needs to be carefully defined. Thus, establishing the elements of the problem and what constitutes its environment. So that's what we mean by systems perspective. Evaluation of the problem includes refinement of the needs and requirements, and information from the evaluation phase may change the original formulation of the problem. In fact, redefining the problem until a consensus is reached may be the most important part of the problem solving process. Okay, so there's a famous line that knowing the problem solves one half of it. Okay, so the next step uh, in engineering economic analysis procedure is to develop or feasible alternatives. Okay? The two primary actions in this step are first, search, number one, search for potential alternatives, of course. And then second is to screen. Okay? Search and screen the alternatives to select a smaller group of feasible alternatives for detailed analysis. So, although we can have as many alternatives as possible, we have limited time and resources dealing with these particular alternatives. Therefore, once we have searched for potential alternatives, we should screen them, okay, so that our resources to are allocated to study or analyze this smaller group of feasible alternatives. Okay? So the term feasible uh, means that each alternative that is selected is judged based on the preliminary evaluation to meet or exceed the requirements established for the situation. So once we have defined the problem, we have refined it, um, we can now tell if a particular alternative is feasible or not, okay? Because we already have defined the requirements, okay, for a particular situation, okay. So how do we select or search for superior alternatives? Okay, in the discussion of principle number one, okay, so principle number one, creativity and resourcefulness were emphasized. Okay, uh, why? So creativity and resourcefulness were emphasized as being absolutely essential to the development of potential alternatives. Okay. The difference between good alternatives and great alternatives depends largely on an individual's or group's problem solving efficiency. Okay? Such efficiency can be increased in the following ways. So number one, how do we increase our efficiency? So that we can create superior alternatives. Number one, we should concentrate on defining one problem at a time. So in step number one, in problem recognition, definition, and evaluation, we should concentrate on redefining one problem at a time. Next, another way is that we can develop many redefinitions of the problem. Okay? So that's another way. Third, let's avoid making judgment as new problem definitions are created. Okay? So do not jump into conclusion whenever a new problem arise. So another way is to attempt to redefine the problem in terms that are dramatically different from the original step number one, okay, on how you have defined the problem. So in that way, uh, you can be more efficient in searching for alternatives. Okay. Lastly, as an additional way to increase the efficiency of searching for great alternatives is to make sure that the true problem is well researched and understood. In searching for superior alternatives or identifying the true problem, there are several limitations uh, exist. So that include number one, of course, the lack of time and money. Second, preconceptions of what will and what will not work. Third, of course, the lack of knowledge. Okay. Consequently, the engineer or the project team will be working with less than perfect problem solutions in the practice of engineering. So we cannot discount that there are several limitations that will exist or actually exist in analyzing the a particular design. Okay, so that's the first primary action. Okay, searching for superior alternatives. Okay, so under step number two, once we have searched for the superior alternatives, so I mean many, no. Uh, the next action would be to develop investment alternatives. Okay, so there's a saying that goes, "It takes money to make money." There are usually hundreds of opportunity for a particular company to make money. Engineers are at the very heart of creating value for a firm by turning innovative and creative ideas into new or re-engineered commercial products and services. So there are uh, approaches in in developing sound alternatives by removing some of the barriers to creative thinking. So the key in developing alternatives is creative thinking. Okay, so some examples are, let's say, classical brainstorming. We have what we call as the nominal group technique. So I will not explain that because we are discussing the steps on the engineering economic analysis procedure. So for the third step, so first step, problem recognition, definition, and evaluation. Second step, uh, search and develop feasible alternatives. Third, development of the outcomes and cash flows for each alternatives. Okay? This step of the engineering economic analysis procedure incorporates the second procedure. Okay? The second principle, the third principle, and the fourth principle from what we have discussed. Okay? So develop the outcomes and cash flow for each alternative. Okay? So this step uses the basic cash flow approach employed in engineering economy. So a cash flow occurs when money is transferred from one organization to another. Therefore, a cash flow represents the economic effects of an alternative in terms of money spent and received. Okay? So consider the concept of an organization having only one window to its external environment through which all monetary transactions occur, receipts of revenues and payments to suppliers, creditors, and employees. The key to developing the related cash flow for an alternative is estimating what would happen to the revenues and costs as seen at this particular window. Okay. The net cash flow for an alternative is the difference between all cash inflows, and cash outflows. So, cash inflows means receipts or savings, and cash outflows means costs and expenses during each time period. In addition to the economic aspects of decision making, non monetary attributes often play a significant role in the final recommendation. Examples of objectives that, other than the profit maximization or cost minimization, that can be important to an organization include the following. So, number one, these are non monetary factors. Okay? Number one, meeting or exceeding customer expectation. That's number one non monetary factor that often play a significant role in the final recommendation. Number two, number one, customer satisfaction. Number two, safety of the employees, customers, or the general public. Number three, that is a non-monetary factor, is of course improving employee satisfaction. Okay. Fourth, uh, maintaining production flexibility to meet changing demands. Those are factors that cannot be measured monetarily. Fifth is meeting or exceeding all environmental requirements. Okay, so and lastly, uh, non-monetary factors such as achieving good public relations or being an exemplary member of the community is another factor that that plays an important role in the final recommendation. So the fourth step of the engineering economic procedure is the actual selection of the decision criterion. Okay? So we have recognized the problem, we redefined the problem, we have searched for superior alternatives, we have developed them, we already know the outcomes for each of these alternatives. For this step, we should define, okay, the criteria or criterion. Okay? The selection of a decision criterion incorporates principle number five. Okay? So, principle number five, we mean consider all relevant ideas or consider all relevant criteria. The decision maker will normally select the alternative that will best serve the long term interests of the owner of the organization. Of course, it is also true that the economic decision criterion should reflect a consistent and proper point view that to be maintained throughout an engineering economic study. Okay? So this step, selection of a criterion, uh, is important. Okay? So the decision maker will normally select the alternative that will best serve the long-term interest of the owners of the organization. Next, step number five, analysis and comparison of the alternatives. Analysis of the economic aspects of an engineering problem is largely based on cash flow estimates for the feasible alternatives selected for detailed study. A substantial effort is normally required to obtain reasonably accurate forecasts of cash flows and other factors in view of, for example, inflationary uh, or deflationary pressures, exchange rate movements, or regulatory mandates that often occur. Clearly, the consideration of future uncertainties is an essential part of an engineering economic study. So that was discussed in principle number 6. So when cash flow and other required estimates are eventually determined, alternatives can be compared based on their differences as called by principle number 2. Okay, focus on the differences. Usually, these differences will be quantified in terms of a monetary unit such as dollar or a peso. So, sixth step is the selection of the preferred alternative. So, in this particular step, we are selecting the best among the developed developed alternatives. Okay, so when the first 5 steps of this engineering economic analysis procedure have been done properly, the preferred alternative is simply a result of the total effort. Okay, therefore, the soundness of the technical economic modeling and analysis techniques dictates the quality of the results and the recommended course of action. So, yeah, that's it. The, the soundness of the technical economic modeling and analysis techniques dictates the quality of the results and the recommended course of action. For step number 7, uh, as implied in principle number 7, no, uh, performance monitoring and post-evaluation of results. This final step implements principle number 7 and is accomplished during and after uh, the time that the results achieved from the selected alternative are collected. So, monitoring project performance during its operational phase improves the achievement of the goals and objectives and reduces the variability in the desired results. So, this step is also a follow-up step to the previous analysis, comparing actual results achieved with the previously estimated outcomes. So the goal here is to learn how to do better uh, for future analysis. And the feedback from the post-implementation evaluation is important to the continuing improvement of operations in any organization. So of course, unfortunately, like step number 1, the final step is this final step is often not done consistently or well in engineering practice. Therefore, it needs particular attention to ensure that feedback uh, is ongoing and subsequent in the subsequent studies. Okay, so I guess that's it. In this lesson, we have defined engineering economy and presented fundamental concepts in terms of the 7 basic principles, right? Uh, Experience has shown that most errors in engineering economic analysis can be traced to some violation of these principles. We will continue to stress these principles in the following lessons to come. Uh, the 7-step engineering economic analysis procedure, as we have described in this lesson, has direct ties to the engineering design process. Following this systematic approach will assist engineers or managers in designing products and systems and in providing technical services that promote the economic welfare of the company um, they work for. Okay, this same approach will also help uh, these engineers as as individuals to make sound financial decisions in their personal life. So, in summary, engineering economy is a selection of problem solving tools and techniques that are applied to engineering, business, and environmental issues. Common, yet often complex, problems involving money are easier to understand and solve when you have a good grasp of the engineering economy approach to problem solving and decision making. The problem solving focus of this study or course uh, hopefully will enable you to master the theoretical and applied principles of engineering economy. So do not forget or always remember the 7 basic principles of engineering economy. Okay, so along the way on the uh, lessons to come, we will continue to give emphasis on these 7 basic principles so that it will always be recalled. Okay, so I think that's it, and see you next lesson. Thank you.